The temperature in New York currently is 70 degrees.
70 degrees. 70 is pretty nice. I think this room is finally getting beyond 70. Okay, so I started grading homework. So if we submitted the homework until like about 3 p.m. or so, it's probably graded. So I will respond with the got it email. That means that it's check marked, it's done. If you got the got it email, it's done. You're ready to be submitted. So anyways, last week, what did we do?
He posted on the website.
Activities, limited nature of projects and how
We talked about like what is the project and why do we care? Yeah.
our project champions, what a project manager does.
Well, the most important thing about a project, right, is that it's something that has a start and an end, right? The other thing, the other actually terribly important part of the project is that we expect to get some corporate value out of it. Like whatever company that we're working for is expecting to get something out of the project. Otherwise, what's the point of doing it? That something is very often money, but it could be other things. Like could be like new capability or something, whatever. But we do expect some value from the thing that we're creating. Right? That's pretty much it. And the other things that are mentioned, things like
He needs help to discuss. 232. Supposed to be 232.
Who's the instructor?
And that is.
Who's the instructor? No, the teacher. Who's the teacher?
Professor Ryan is AMIS instructor.
It's today, right?
Well, the class is not today. It's on Tuesday, sorry.
It's Tuesday. Is it a T
So,
or a
8 to
TH?
10.
Is it a T or a TH?
Ryan is.
Yeah. Is it a T or a TH?
TOTH. What about that?
Which day? Is it Tuesday or Thursday?
Thursday.
You sure?
Yeah.
Well, I think it's Tuesday. I suspect it's Tuesday.
First, which class is on about?
MIS.
It's Tuesday.
It's Tuesday.
Yes, Tuesday. Yes, Tuesday. It's not today, it's Tuesday.
So T is a Tuesday and TH is a Thursday.
This one is Tuesday. Yeah, the class before.
You're welcome to stick around for IT project management.
Yeah, you had it earlier, right? Yeah, that's Tuesday.
Cool. Okay, where were we? So the other things that we discussed are various roles that people play in this whole enterprise of we notice something that can be done, we initiate something that will improve something, and then who is coordinating the fact that we build this thing from scratch and implement it in the company to get that done, right? Obviously, there's like things like estimation and all that stuff, but essentially the important thing is that it's something that's temporary and something that we expect to get something out of. Okay. That's the important bits. So today we're going to talk about that important bit of the beginning and the end part. So if you think about a life cycle, so there's a lot of arbitrary terms in this whole enterprise. If you think about the life cycle of a flea, for example, right? Or whatever. A flea is born, a flea dies, right? You can say, well, there are two events, birth and death, right? And everything in between, right? Or you can say, well, in between there's also parts, like there's a baby flea, and there's the old flea, and there's a middle-aged flea, and so on and so forth, right? So now, who decides how many of those slices that you make? It's arbitrary, right? Like for example, you could take a human lifespan, right, and say childhood, middle part, and old age, right? Or you could say, well, there's the teenage years, there's the middle age years, whatever, there's whatever retirement years and whatever, and then very, very old years, right? Yeah, I don't know how to pronounce that word. But the geriatric years. Yeah. The thing is that, now again, who makes these, defines the boundaries? Us, it's arbitrary, right? So same thing for a project, right? We know that project needs to have a start, we know that it needs to have an end, right? And then what, right? So we generally subdivide it into several layers, right? One layer is figuring out what we're doing, the doing part, and wrapping it up part, right? And that's generally the way that projects work. I mean, you could say, well, we're gonna have 3 parts, I'm gonna have 5 parts, I'm gonna have 17 parts, whatever, it doesn't really matter, right? Now, the figuring out part, what we're gonna do, is very often subdivided too. Very often you say, well, the rough guesstimate of what the project is, estimation phase, figuring out the costs for this thing, planning for it, so on and so forth, right? Now, the doing part, you can say, well, how are we actually doing the project? Well, let's say we're coding it, right? Something like, okay, how do you code things, right? Well, you review the requirements, you design the system, you code it, you test it, you deploy it, right? Right. So even those big parts can have subparts, right? How do you code things? Take a function, you look at the requirements for it, you code it, you test it. Even those small little bits have life cycles, right?
Life cycles for a project.
Exactly. So the thing is that the basic idea is that everything has life cycles. The whole project has life cycles. So typical life cycles: define the goal. These are class notes. Defining the goal, plan which route you're going to take to the goal. Objectives. So objectives are the thing that's going to drive your, I guess. So the whole project has a. You want to achieve something with the project, right? And the objective is the thing that you're trying to achieve. If you don't achieve the objective, it's kind of pointless to the project to begin with, right? So the objective needs to be very clearly defined at the beginning of the project. It's not like, oh, we would like this new billing system because, we want to upgrade, right? The want to upgrade is not a good objective. You used to have, well, you know what, the old billing system costs us $10,000 every 3 months to maintain. The new one is only going to cost us $2,000 every couple of months to maintain, or something like that, right? You need to have some sort of good numbers to those objectives. Resources. Typical life cycle. Oh, well, that's not a life cycle.
It's not.
Did you want it to be projected in the
What?
project?
Sure, why not? Oh, so it was on. I was just thinking. Okay, it's turning off right now. So now the thing is that once this thing comes up, we'll talk about the actual life cycles. Now, as project managers, right? What's your role in these life cycles?
Control.
What?
Control.
Control. But what exactly does it mean?
Make sure every phase is having good time. That's how it is.
Exactly. One, keeping track of where you are within the life cycle. That's one, right? Recording events like business events that advance you within the life cycle, right? If you're transitioning from one phase to another phase, you need to say, well, I have something to prove that I actually transitioned correctly. Now, very often that proof requires some sort of an artifact. Like, for example, if you go from design phase to implementation phase, right? you need to have some sort of a design document that says, well, you know what, the design phase completed, I have this design document to essentially, as my artifact for the design phase, means that my design phase is complete, I can do development off of that design document, right? Again, as managers, ensure that that design document is in place before you start development, right? And these things, I mean, they will not happen magically. They will not happen on their own. You need to actually, you as a manager need to drive these things. You say, well, this document needs to exist. Let's get everything on paper, right? But yeah, it's all record keeping. A lot of it is record keeping. Goals, ensuring project goals and objectives are met, execution of project plan, project end, valuation. So yeah, typical life cycles. Define the goal. Yay! There you go. So understanding and framing the problem, plan it, act it, reflect and learn. That's essentially life cycles. Typical life cycle is define the goal. Again, this would be something where so very often the projects will actually start way ahead of this planning phase, the definition phase. Very often a need is identified. Right? Now, who identifies the need? It depends on company to company, but essentially the need becomes known to management in a position to do something about it. Right? At that point, somebody needs to say, well, let's define it first. Like, what is this need? Right? You define the need. Like, we're going to build a new accounting software. And then you say, well, do we really have to build it, or just buy it? And that's all part of the project of getting a new accounting system in place. You could buy it, you could build it, or you could do nothing. All of those are valid options. And depending on the situation, those could be very, very, very valid strategies for a new billing system. I mean, do nothing is a very, very often used option. So plan for it. Provides a route, objectives, scope, schedule, budget, quality. Again, scope is very important. Are we just doing the billing system, or are we doing everything around it too? Do we need to do reports? Do we need to interact with other systems within billing, I mean within accounting systems or something? Like how big is this thing that we're tackling? Sometimes very small little things actually tackle surprisingly lots of connections. Like within organizations, lots of things are connected. Like, for example, if you think about like a list of customers, right? You have a list of your customers, and pretty much everybody uses list of customers. Like the people who do advertising, they use list of customers. The people who do billing, they use list of customers. The people who do field help desk calls, they use list of customers. So you can say, well, I'm going to make a small change to the list of customers or something to improve blah, blah, blah. Suddenly you're impacting like 12 different sub-organizations. Okay. So the scope needs to be like, I'm only going to touch one thing and nothing else. So the scope is going to be, I'm overhauling this whole customer management business, and everybody's going to have to adjust to it. Schedule. So lots of problems, if they're solved in 3 months, they're very useful. If they're solved in 2 years, they're not. So very often especially like nowadays, like, but I can imagine the conversations that are being held like at Google and OpenAI and whatever, and they're like, yes, we can build this new extra super like GPT-5 in 2 years, and they're like, no way, we need to have it in less than 6 months, otherwise Google's going to catch us. So yeah, objective to be, I want to be first to market, otherwise our stock is going to fall. Budget, again, if something is too pricey, then it's probably not worth doing, or at the very least, you might find other more lucrative things to do with that money. Quality, again, it's, depending on what you're building, quality matters. Like SpaceX blows up a rocket, it costs a lot of money. And it could be because of something stupid that the rocket blows up. In fact, very often rockets blow up for something stupid, like somebody forgot to convert imperial units to metric units, and bam, you have $500 million lost. So, yeah, quality is important. Resources, people, facilities, technology. Yeah, not necessarily life cycles. Controls, ensuring project goals and objectives are met. Execution of project plan, project end, evaluation. So, wrapping up a project is important. You don't want to have a project that just keeps on going on and on and on and on. I've seen those happen. They never end well. So very often those projects they transition to maintenance. Like you have a project that builds a new system, and then very gradually all the developers leave, and the only people who are left, they're doing just maintenance. It's still a project, but it's actually a different thing that the team is doing. They're not developing anything new, just essentially doing. So it's very important to just wrap it up and say, you know what, from now on, we're no new development, we're on maintenance mode, enhancement mode, maintenance mode, so that one, people can actually move around, like the developers of the project can move around and leave with a clear conscience that they're not really, there's no new development going on, and they're not like really needed in the project or something. Evaluation. So the success rates of projects is very low. So whenever you have a success or a failure, it's kind of important to figure out why did it succeed or why did it fail. Like what were some dangerous bits of it that you want to avoid next time? So usually that's one of the things where we're like, what went wrong, what went right, kind of thing. But the idea is that does the project meet its stated goals? Right? Is it bringing value to the organization? Right? How could it have been done better? Like in retrospect, hindsight is 20/20. Like you can see stuff very clearly once it's in the past. Like, oh yeah, we should have done that, right? So the thing is that nobody can see the future. So when you start a project, you have no idea what's going to happen in 3 months. 3 months later, you can say, now I know how we should have tackled that problem, right? So evaluation is important because one, it lets you repeat these things in other projects. In a lot of cases, individual projects aren't as important as the team that actually builds them. The more mature the team, the more other projects they can tackle. So, in other words, don't view a project as something that's critical and must succeed. If you learn something from a project, it's okay for a project to fail. Just avoid the same mistakes on the next project. The whole organizational value thing, it depends on portfolio projects. Like within the organization, you're going to have a dozen projects going on at any given time. It is expected that a fraction of them will fail. Very often that fraction is large, like 70% of projects fail. But as long as the organizational value comes from even 30% of those projects, it's okay. So that's actually one of those kind of counterintuitive things. Very often value comes from a tiny fraction of something. For example, S&P 500. how many of you invest in S&P 500? Like you buy an SPY ETF or something, or the VU ETF, right? How many of you are aware that only about like, I don't know, maybe 10 to 20% of S&P 500 actually makes any money? Like over the long haul, over like 5 to 10 years, only a tiny fraction of companies are going to do well. The problem is that one, you don't know which of those companies do well, right? Otherwise, you would just buy those companies and ignore the losers, right? But the reason that the S&P 500 works is because it has such a large variety, and you can't afford to have like 90% of the companies do really poorly, as long as those 10 that are in there do really, really well. Right? So it's okay if some projects fail, as long as some the other ones actually make up for the failures. Okay, knowledge areas for management. Project integration management, development, execution, and delivery. So this is actually kind of important. So first things first, as a manager, record keeping is important. I know I'm like going over it like a record, like a broken record. Record keeping is important. Developers, they don't really keep records. Pretty much nobody else keeps records. Things like when you call up a person to do a design meeting. I would recommend keeping track of literally the entire day. Like you get to work, you chat with the developer, make a record of it. At this time, that was the finding. That's what I've observed. 2 hours later, you have another meeting, make another record. I had a meeting on so-and-so, that's what I've observed. 2 hours later, you have another meeting, that's what I've observed, right? Next time you have a meeting with a developer or something, you can refer back to notes that you took during the last 2 weeks, and you can drive the conversation. Record keeping is important. Change management is also important. Things like, the thing is that in order to be able to correctly steer the ship, like you're steering the project ship, you need to observe where it's going and where it's been. Actually, in order to know how to get to places, you need to know how to steer the ship, and you need to have an idea of where it's been before. So record keeping is terribly important. Project scope, again, the project manager is the one that actually controls scope. It's very often is the project owner or whatever, but project scope is something that determines budget, determines the difficulty, determines the length of time it's going to take and everything. Very often changes are if somebody wants changes, they very often approach the project manager saying, oh, we need to have so-and-so feature. You need to be able to say no. If it's not a critical feature, it's not going in. If it is a critical feature, yes, we're going to adjust the budget and everything. So you need to be like the gatekeeper for changes. Time, cost, quality, again. If somebody introduces a change, right? Let's say you do need to change something, right? That will cost you time. Now, time means you need to have the team for a little bit longer. That involves people, right? That involves cost. So pretty much every change revolves back to time, people, cost. Right? It's not, very often it's not straightforward how to translate one thing into the other thing. Like for example, if somebody says, hey, we need this button implemented, it's very hard to say, well, this button is going to add, I don't know, $3,000 to the cost of the project. But it will cost money, because somebody needs to work on it, somebody needs to develop it, somebody needs to test it, somebody whatever. So, but it's very hard to say that this button costs $2,000. So, but yeah, project managers need to be able to push back on these things. Human resources. People are not the most important resource, because very often people are the costliest resource. until, as I said, until recently, like the big GPU clouds that the companies are renting, your time was worth more than the computer time. Now that you can allocate a cluster of 1,000 GPUs or something, suddenly your time is just a tiny fraction of what the computer costs. It's kind of inverted reasoning. Development projects as a team, there's full understanding and responding to the Windows side of the work. So, it's not just technical stuff that you'll be solving. People will get sick. People will take vacations. Like, I need a vacation and I can't log in for 2 weeks. Or 4 weeks. Or they might quit. You need to be flexible, and sometimes you have to be like super flexible, sometimes you can be like hard on flexibility wise. The thing is that I generally take the stance of if the work is not impacted by anything, I don't really care. Like I had one of my folks wanted to work from Atlanta for a month. I was like, I don't care. This is pre-COVID. People showed up in offices then. Nowadays, lots of companies, they actually implemented this in-office policies, which are great in some sense. But you need to make exceptions in exceptional cases. And some people, they do need to stay in other states. Some people need to drop off and pick up kids. And schools are not necessarily aligned with work hours. So you can't like really say, no, you have to be in office at 8. I've had managers who told me that. And yeah, that's my point. So the story goes something like this. In year 2001, in January 2001, I was working in the World Trade Center, and I had disagreements with our manager before. And one morning, the guy said, "You showed up like 9:30 or something." And I was like, I worked late last night. Come on, cut me some slack or something. And yeah, we had a disagreement about me showing up late. I quit. And best decision I made. So yeah. I still have the World Trade Center badge. That was Deutsche Bank.
Is that before 2001?
What?
Was that before 2000?
2001. So in January 2001 is when I quit and started my own company. That went nowhere because that was the dot-com bubble. That was it was just anyways, communication. But my point is that human level management is also important. You do need to manage people, not machines. You need to be aware that people do have lives outside of work. And sometimes, like 9 times out of 10, the requests that employees make are very reasonable. By reasonable, I mean like picking up kids, dropping off kids, so on and so forth, like vacations. Sometimes they're not reasonable, and you have to be like, it's a case by case thing. Like if it sounds reasonable to you, it's reasonable. If it's not reasonable to you, it's not reasonable. But just be aware that if you were in that situation, what would you want to happen? Okay, communication. So managers can facilitate all the communication. So now, suppose you have a small little project team, right? Of let's say 10 people, right? And you can say, well, it's just 10 people, everybody talks to everybody, right? Just like this class, everybody talks to everybody, right? How many lines of communication do you have? Yeah, that's a heck of a lot of, like, let's say you have a WhatsApp group and you have everybody in the class is a separate contact in the WhatsApp group, right? If you wanted to speak with anybody, you would just like WhatsApp just that person, right? That's a heck of a lot of lines of communication. It's much more efficient to bubble up your problems to the manager, or manager to disseminate it to everybody. The hub, be the communication hub. It's primarily to cut the number of communication channels. Risks. So there are lots of these risks. Some risks are so there's a difference between uncertainty and risk, right? So risk is something that you can imagine and you can plan for, right? So in other words, risk would be your developer leaving, right? You can say, well, if any one of my developers leaves, I don't want the project to go bad, right? So what I'm going to have is I'm going to have every developer knowing at least 2 tasks, like their thing and somebody else's job. Or every developer knowing how to do at least 4 things, right? In which case, one developer leaves, you just hire somebody else, and so the whole project can go on. It's not like one person knows one thing, and if they leave, the project is screwed, right? Right? You can plan for that, right? Something not turning out the way that risk is something you can plan for, and very often prepare for or insure against. Now, uncertainty is something, it's whatever else is left over. So in other words, you take out insurance for risk, right? Like, for example, the house might burn down, so you take out an insurance policy for fire insurance, right? That's risk. Aliens could come down on whatever, and you don't insure against the aliens, right? That's uncertainty, because we don't know. For all we know, next year we could have ChatGPT Terminators walking around and just taking over the world. Uncertainty. What is at risk? But generally, if you can imagine the problem and think about what the consequences of it would be, it's risk. And whatever else that's left over, something that you can't even imagine, is generally uncertainty. So both risk and uncertainty can derail a project. But at least with risk, you have a chance of some sort of remediation action. Procurement, resources, as I said, the organization. Very recently, procurement very often means buying compute on the cloud. You need to have enough budget for that. Problem is that lots of folks don't realize how expensive it is until you actually get hit with those bills, and then suddenly people start dialing back their usage of the cloud. So on the surface, the cloud is much cheaper than having on-premises computers. Now, if you were to set up a cluster of computers in the office or something, right? It would cost you a certain amount of dollars. Let's see, $100,000 to set up your own mini data center, right? Now you can say, well, I could rent the same resources on Amazon or Google or whatever, right? And it only cost me $2,000 per whatever, per week or something, right? The thing is that you expect it to be $2,000 a week. It turns out to be $17,000 a week. And then at that point you're like, wait a minute, it would have been so much cheaper to just buy your own resources. But then people overlook the fact that they probably would need to hire people to set it up. They would need to hire security guards, they would need to have proper ventilation for the data center, they would need to have whatever. There's all these other costs that Amazon is cheaper. Now, that said, very often the costs for internal computers or resources, or the compute resources, are already paid for. In other words, you allocated the budget for it at the beginning of the year, and you buy them, and then they're sitting there, and unless you use them, you lose them. So there's a lot of incentive to actually hit as many things as you can against those computers. Like, they keep those computers as busy as you can, right? Amazon is kind of the reverse of that. Amazon is you allocate only as much as you want to use, and if you go with the use them or lose them kind of strategy against Amazon, you're actually going to end up paying a lot more. So in other words, you should be non-conservative with resources, with computer resources that you bought. And you should be very, very conservative with the rented resources. Because every time you use them, you're paying for it. Also, Amazon fees are very visible. Like let's say you pay $100,000 for a database, right? 3 months from then, all the managers, you already forgot about the $100,000. They just know that they have a database that's sitting there ready to be used for free. Right? Because every query that you run, you don't pay for the queries. The database is already there. You're not paying for it. With Amazon, every time you run a query, you're paying for it. Those costs are very visible to managers. And suddenly you're like mentally thinking, if I query this database, it costs $300. Like every time I type a statement, it's $100 here, another statement $100, another statement $100, another statement $100, and you realize that you just wasted $10,000. So suddenly that puts a damper on experimenting. And it's a real thing. I mean, I used to experiment with data a lot until we started running stuff on the cloud, in which case, like, all the costs became very visible, and we started experimenting. And that's kind of bad for the development team. If the development team was kind of concerned about money to experiments and stuff. The other thing is that stakeholder management. So IT projects, project managers, they don't just manage down. They also need to manage up. Managing down means that everybody who's working on a project goes through the project manager, right? You need to make sure that like everybody's doing what they need to be doing and so on and so forth. You also need to be managing up. In other words, to your managers, keeping them in the loop on major things, keeping them out of the loop on small things, making sure that the upper management hassles don't really hassle your team. That's very important. The thing is that at the upper levels, you can have shitstorms. And your job as a project manager is to hold the umbrella and shelter your team from that. Like reorg is happening, whatever, you need to make sure that nothing touches your team. Right? The other thing is that it's kind of important to keep, so you might have chats with your manager, with your team, right? Very often those chats become, the thing is that, yeah, it depends on the organization, depends on how comfortable you are with the team and so on and so forth, but very often the team is going to be open with you about the actual like, day-to-day problems they're having. If you bring in a senior manager into the status meeting, for example, the team is going to clump up and not going to open up and share what the actual problems are. In other words, you could have the team telling you like, there's no way we'll be able to make this in 2 weeks, right? And you know it, the team knows it, everybody's working on it. As soon as the upper manager, like one of the stakeholders or project owners walks in, the team is not going to say, there's no way this will be done in 2 weeks. They won't tell you that, they will not be as open. So as a manager, you have to keep the upper management out of the affairs of the team. Like there needs to be this information buffer. The thing is that very often I know that it's a good idea to pad your deadlines. In other words, your team may think that the deadline is in 2 weeks, but in reality, you know that everybody's going to be okay if you deliver it in 3 weeks. Right? Because you've told the upper management it's going to be delivered in 4 weeks. Netflix, everybody does that. How many of you, Star Trek? Scotty in Star Trek. Miracle Workers, there's a quote, something where Scotty pads estimates. I got the name of the, which was in. How long would it be to take? There's a Star Trek episode where Scotty, the old Scotty from the original series, and Jeffrey LaForge from the Next Generation series, and so LaForge gives an estimate to his captain saying, oh, this will take so many hours, like 6 hours or something. And Scotty says, how long will it really take? And the guy says, 6 hours. My God, you didn't pad your estimates? So yeah, everybody pads estimates. And yes, unless you're a Trekkie, that would just be completely like, what is he talking about? I'd recommend picking up Star Trek.
Oh.
Even though their tricorders are less advanced than our cell phones.
Yeah, but they can scan stuff, right?
So can we. My phone tells me.
QR code.
Yeah, QR codes, we can tell temperatures, we can like, tell our pulse and whatever. We're getting there. Communicators, our phones are way better. Process. Okay. Okay. Activity with inputs and outputs. So here's my view on every single corporation, right? So yeah, abstractly, right? What's a company? It's like a mechanism, right? That you push money into one end, and more money comes out the other end, right? Now you can say, well, it's not just money; it's resources, but everything at some point is convertible into currency, right? So you can say, well, it's people, machines, and some raw materials and time or whatever. But yeah, at the end of the day, it's just a black box where you push stuff in and more value comes out, right? So same thing with projects and other things too. So project management process. So the thing about, if you view it as a process, right? Let's say you view it as an engine, like a car engine, right? Like a 4-stroke engine, perfect. Like why did so most car engines are actually 4-stroke engines. In other words, like the engine actually cycles 4 times for every time that piston explodes. So it explodes, and actually there's 4 iterations until it explodes again. Those other iterations are to kick out the old burnt gasoline, then to bring in new gasoline, and then pressurize it and explode it, and it's like it explodes on every 4th iteration or something. So anyways, why do I bring it up? Companies are kind of like that. So there's machinery within the company. I mean, a company is essentially a machine. Things don't really happen haphazardly, right? Like you walk into a huge organization like an insurance company or a bank or whatever, right? They have, let's say, 17 internal departments or something, right? They have, I don't know, 10,000 employees. It seems like everybody's doing something, right? Everybody's working on something that nobody else is concerned about, right? The thing is that every single cog in that machine is like a small little part of an engine that generates revenue. Like you have an actual like car engine, right? That generates movement from burning fuel, and every single piece is moving, right? Every single bit of that engine is important. Like you remove a wrong screw from the wrong spot, the engine is going to stop running. or it's gonna break apart, or something's gonna happen, right? Most companies are the same way. Is it? And it might seem like like everybody's working on something, but there is a process where everybody's doing something that's critical to the business success. And if they're not, then they shouldn't be in the company. I mean, lots of folks who are not doing really anything critical, but for the most part, you can view a company as a machine where every single bit is kind of important in some way. And now, everybody follows the process. And it's like the four-stroke engine has a cycle. It's the same with all the companies. They have a cycle. You do something every day. You do your job. Now, your job may be different every other day. It may vary, but your function within the organization doesn't really change that much, like with every cycle. Right? Let's say every person is a cog in this machine. In this machine. I'm not saying that cogs can be replaced with other cogs, but maybe they're very specialized cogs. But yeah, everybody's playing their part for this whole machinery to work. Now, I mean, that's actually to say that if you don't have a process for your project, you're doomed. And I'm not big on process. I hate process. But you need to have a process in order to succeed, in order to move. Like if everybody starts doing whatever without any sort of process, then you're going to be stuck. Initiating project process, business case, planning phase process. Scope planning, activity planning, executing. So these are the things that you do inside the project. So first you initiate the project, create the business case for it, plan it, scope it, activity planning, things like who's going to do what. Executing it will be development. So this whole IT project in our minds is probably some sitting down and programming something. This is just one bullet point for this whole project. This is the programming part. Monitoring and controlling progress metrics and closing. As I said, the actual R&D, the actual software development part is just this. So project managers will be involved in all of these. Particularly, this is the longest and most expensive phase. But it's probably the only technical thing in this whole phase.
If you were going to pitch a product to a potential client, how far along do you think, like I want to develop an app for a particular idea, and I have a particular client in mind. How much do I need, how far along does that need to be? Do I need to get it?
Well, do they have a need?
Yeah, they're unaware of the need. They're unaware of the need.
Highlight the need. So, how many of you saw the movie Wolf of Wall Street? Yeah, there's a small episode where sell me something, and sell me this pen. Well, write something down. That's how you get the need for the pen.
Okay, so I'd say yes, they have a need.
So yeah, identify the need and make sure that the managers are aware of the need and agree that the need exists. And that's how most consultants actually sell stuff. The problem is that very often you're not aware of the actual need. And you show up selling something that they don't really need. Or they already have a solution for it. And so, again, backing up a few years, I used to work for a financial regulator. And the whole idea of financial regulation is that you get a data set and you look for anomalies in them, right? That's what regulator does. They look for anomalies trading, right? Now, you wouldn't believe how many consulting firms would show up and try to sell us anomaly detection software for the data. And I'm like, you have this organization that prides itself on building its own anomaly detection code. And you have vendors coming in trying to sell you anomaly detection software. There's no need. And yes, their software may work, but it's not the regulatory software. So yeah, castrate and lead. There's a very good book, Start With Why.
Why?
Yeah, Start With Why.
Is that a sales book?
Yeah. Actually, it's a good book for everything.
Okay.
Yeah, Start With Why. Oh wow, few books.
But if you were gonna demo something, how far, like, would you do a full production
I would
model
start with why.
for demo?
I would start with, everything starts with a why. So, the thing is that, as I said, you don't actually know what the problem is in most cases. As I said, lots of times you're not really aware. There's a market for lots and lots of cool new things. I've seen companies make money by analyzing internal emails and predicting which employees will leave. Like, who knew that companies pay money for that stuff? But they do. And it's crazy. It's like, there's a company that makes its money from reading internal company emails and predicting which employees are retention risk. Seriously, there are companies. Yeah, I spell that a lot. There you go. I didn't even know this company, but there's like a lot of these companies. My God, see? If you find like at least 5 companies doing it, just doing a plain cursory Google search, you know that there's money to be made in this. All right. Okay. Oh, customer retention. That's another thing. But yeah. Anyway, SDLC. So SDLC stands for Software Development Lifecycle, and this is essentially this bit over here, the executing part. And lots of you may be familiar with all of these statements. And essentially, in order to build software, you need to plan it, analyze it, design it, implement it, maintain it, and support it. Now, support feature is not really part of projects, but it should be part of some sort of support function once the project is over. Do I need to go over any, like, what do we do in these phases? We probably will eventually at some point when we discuss it, but anyway. Project lifecycle focuses on phases, process, tools, knowledge, and skills, and whatever. Yeah. SDLC focuses on creating and implementing a project. So the lifecycle is different for the project versus SDLC. So the thing is that you don't start SDLC until you actually start building the thing. But you don't start building the thing until you actually figure out what you're building, why you're building it, what value will it bring, and so on and so forth. So there's a lot of stuff that needs to go on, that needs to happen before you start telling developers to start coding, right? SDLC is part of the project lifecycle. Much of development happens within the execution phase of the project lifecycle. Okay. In the olden days, so I'm pretty sure everybody has heard of waterfall at some point. Like some of you may have taken a MIS class or something. Anyway, waterfall. days of building software. And by olden days, I mean like 1990s. You used to essentially say, guesstimate, that a certain project of a certain size will take, I don't know, 9 months or 3 months, or whatever. I don't know why there were always round numbers in terms of 3 months. They were always like either 3 months, 6 months, 9 months, 12 months, I don't know why, really. But anyways, waterfall was the thing to do. And essentially the idea was that you define requirements for the thing that you need to know. I mean, this is past the project definition. This is like, you already know that there's a need, you already know what needs to be built, whatever. You need to define requirements. Now, requirements actually control scope, but at that point you're like, you already know what needs to be built. So requirements would be like fine-grained details of things. You need to design it. Design means architecting it, designing it. If it's a GUI, what are the GUI components? How will it interact with the database? How will it interact with the backend? So on and so forth. You need to design how the thing is going to work before you start coding. Then you have to build it, actually like sitting down and typing up the code, or asking ChatGPT to do it. Then you need to test it. Now, you generally test it to the requirements. Like, is this code meet the requirements? Right? Now, again, think about all these phases, and where does ChatGPT fit in? I mean, the thing is that we're hindsight, right? We've already had ChatGPT for like almost 2 years, right? Yeah, 2 years-ish. Okay, what things can ChatGPT do? And we know that it writes. We know that it can write code, right? Would you trust it to tell you that this code is correct?
Garbage.
No, the thing is that define requirements. Would you trust it to define requirements correctly? Would you trust it to design a system? Would you trust it to build it? Like, once you actually have the correct specification, like let's say you have prompt. I mean, think of these things as prompts, right? For ChatGPT. Once you give it the correct prompt, the assumption is that it will output correct code, right? Would you trust it? Would you trust it to test it? I mean, the thing is that when ChatGPT first started programming, I was like, perhaps we'll be all out of a job. Right now, I'm actually starting to realize that's probably not going to happen. Yeah.
So how long do you think until we're all out of a job? Like 50 years?
So as I've said, I don't think these things are solvable.
Uh-huh.
As in, like, let's say they're solved, like, you ask it to do something and it doesn't, right? One, the problem is that every time you ask it, it could give you a different answer. Like, you ask it to generate an app, it generates an app. You ask it to generate an app, it generates a different app. So it's not consistent. And yes, even if you force it to be consistent, which I don't think they can, I mean, consistency wouldn't necessarily be useful, because you do need to explore that space.
I kind of feel like even if it gets more powerful, you're still going to need somebody that knows how to
You still need somebody
to go in
one,
there and
figures
fix
out that there
that.
is a business need for something,
Uh-huh.
and correctly defining the business need, correctly implementing it, and making sure that it actually does solve the business need.
Or you can't just like add a button. You know how hard it is to add a button.
Well, adding a button is probably easy.
With the front end, but what that button actually does and like.
Yeah. So the thing is that I wouldn't trust ChatGPT much in these things. I mean, yes, it does. It is a really good impersonator of intelligence. But as I said, if you can be seriously embarrassed by if your system breaks or produces wrong output, you wouldn't use ChatGPT. Like, you wouldn't use ChatGPT to say to design like airline software or something, because you can test it once. Hey, plane didn't crash. Tested it 100,000 times. Plane didn't crash. You can't guarantee that it will not crash. I mean, would you fly in that airplane? That's the thing. Anyway, deploying and maintaining it. As I mentioned, the maintenance is kind of weird. It's not really a project. Anyway. And then there's Agile. So, at some point I started hating software development. Like, this was the dot-com bubble, and I started hating it because I actually applied for an accounting for an MBA at Baruch College, and I was actually accepted into the MBA, but I never actually went through with it. I mean, I started hating it that much that I was like, let me go to management. So the thing is that Agile seemed really awesome. So the first time I read about it, I read the book, I was like, Agile is nice. And the whole theme about Agile is individuals' interactions over processes and tools. Working software over comprehensive documentation. Like, I don't document my code. The code is documentation, right? Awesome. Customer collaboration over contract negotiation. So if you, let's say a customer says, you know what, we really need this feature, and you're like, sign this contract. The whole interaction goes out of the window. Or this thing is going to cost you $12,000 to add this feature. If it's internal software, very often it's much easier to just say, you know what, we'll just add it. And yes, that's what project managers should not do, but they really should be nice to customers. Responding to change over following the plan. So the thing about the waterfall model is that there's no flexibility. Not really flexibility. There's no backtracking feature. I mean, the backtracking is not built into it. So let's say you discover an issue with the requirements, right? Officially, within the waterfall model, there's no backtracking to say, wait, we should go fix the requirements, or we should go fix that, like the design, or we should go fix that. There's no official cycling back. Now, cycling back does happen. Like, the requirements pretty much never stay fixed. Design never stays fixed. But in the waterfall, the official motto is that it's fixed. You sign off on the requirements, you sign off on the design, then you go implement it, and that has to match the requirements of the design. As I said, that almost never happens. But the official motto is that you sign off on the requirements, right? Like there's this phase of requirements, and there's a phase of design, and you sign off on both of them, and you're done with those phases, right? The problem is that causes lots of issues. And people do cycle back, and you might go down the wrong track, and then you have to cycle back, and it turns into a big mess very often. So people invented Agile to essentially say, you know what, let's just do the right thing. Forget about the plan, forget about the fact that the requirements are fixed. We're just going to do the right thing. We're going to talk to the customer and figure out what needs to be done. Just do that, right? Now, it was discovered that lots and lots of these small little problems can be one prototyped and very quickly solved if a technical person meets directly with the customer. Like, so for example, in large organizations, very often developers are actually coding to some sort of a spec, like the technical spec. Now, where does the technical spec comes from? From the business requirements. Where does the business requirements come from? From the upper level, from some subject domain expert, right? Where does a subject domain expert come, gets his knowledge? Well, he's been in the company for 20 years, right? Now, if a developer has a question, very often he refers back to the technical spec, which may or may not answer the question. And then they will bubble up to the business requirements, which may or may not answer the question. They bubble up to the project manager, who may or may not answer the question. They might bubble up to the SME, who might or might not know the answer, right? Wouldn't it be easier if the developer just, you know what, if it's a complicated enough thing, most developers will figure out that, hey, you know what, it's obviously not in the requirements, otherwise it would have been obvious. Somebody would have documented. I mean, if it's not obvious to me, it's not obvious to whoever wrote the business requirements. So why don't we just ask the SME directly? Now, I was talking directly with the customer, or the person who actually knows what needs to be done. It's very often bazillion times more productive. Because one, you not only get the answer, you get the context for the problem. You know, so you learn what the business thing is doing. Like, very often you're just shuffling records from here to there, you're massaging the data this way and that way. Like, what are you trying to achieve? Like, from the business perspective, is what the SME can give you. Right? So that's what interacting directly with the customer. In other words, Agile was awesome. So the theme is frequent releases of working software. In other words, you talk to customers often, and you make releases often, and you show them to the customers, and the customers give you feedback, and then you show them again, and you get more feedback, and very quickly you iterate, and you have a product that customers love because they were part of the process, right? And if there's anything major wrong with it, they would have told you about it like way ahead, right? Integrated testing, and they will put, so now how do you iterate often in software without breaking things? Well, lots of people introduce things like unit tests. Like every time you make a change over here, you want to make sure that you didn't break lots of stuff over there. So you implement unit tests so that whenever you make a change over here, you don't actually, if you did end up breaking stuff over there, you can revert back the changes or make the changes a little differently, right? And so unit tests became a thing. Like suddenly every single company started requiring unit tests. Now, before we move on from Agile, yeah, we're almost done. Yeah, almost done. Before we move on from Agile, lots of companies, they took this awesome idea of Agile, and they said, you know what? We love it. We're going to use the software named Jira, and we're going to implement Agile in Jira. Right? And we're going to have daily stand-up meetings, and we're going to be doing Agile. I don't see daily stand-up meetings here. I don't see Jira here anywhere. We're going to have sprints. Right? I don't see anything about sprints in Agile. The thing is that, and we're going to have tracking. I mean, the whole idea of Jira is that everybody, you know exactly what everybody's working on. So, from the project manager's perspective, here's the Agile versus management. Right? Agile is awesome. Now, implementing Agile within the company, the IT project manager part, is where things get screwed up. That's why developers hate Agile, because of the way that it's implemented. Does it say anything here about estimation? Does it say anything about sprints? Nothing, right? And yet, that's what everybody's forced to do every morning in their Scrum stand-ups.
Do you feel like those things waste time?
Yes. So as far as it's not Agile, but what I'm saying is that it's a framework to track what everybody's working on. And people call it agile, but it really isn't. In fact, it's the opposite of agile. If a meeting has no value, agile says you shouldn't have that meeting. And most stand-ups, they have no value to like 90% of the participants. So, Jira and Scrum are ruining agile. You heard it here first. So yeah, agile is awesome, but the way that it's implemented in most companies is terrible. Now, manager hat on. I'm going to put a manager hat. Agile is awesome. And you know, in Scrum, I know exactly who's working on what. I can estimate my project, right? So as far as the manager is concerned, Scrum is awesome, and Agile is awesome. I know what everybody's working on. I can track things. It lets me, you know, the record-keeping business. Record-keeping is important for a project manager. Jira lets you do that. So yeah. I am a developer. So what went right, what went wrong, that's essentially post-mortem on any project you should be doing there. At the end of the project, you should say, not just the project, but like SDLC, at the end of the development view. At the end of the execution phase, you should say, hey, what went right, what went wrong. Very often, what went wrong is you were using Scrum, not Agile. Learning records. What we know, what we think we know, assumptions, and what we don't know, questions to be answered. And there's also what we don't know, we don't know. And there's lots of things that we don't know that we don't know. Right? Action plans. Who does what and by when. So keep in mind that here's the going back to a little bit about that rant about Agile. Suppose you suspect that a certain thing will take you 2 weeks, right? And you spend time, let's say you spend like, I don't know, half an hour thinking about it, and you come up with 2 weeks estimate, right? And you attend the daily stand-up meetings, and cumulatively they add up to a lot of time. But let's say 2 weeks for an estimate, right? Suppose you sit down and code it, and it takes you, let's say, a week, right? As far as the project development time is concerned, right? What was the value of an estimation? What was the value of spending that half an hour on estimating? Did it make the project faster? No, it still took you a week. If you told them that it was going to take you 3 weeks and it took you a week, same thing. If you told them 2 weeks and it took you 1 week, still it took you 1 week. If you told them 3 days and it just took you a week, the result is the same. It took you a week, right? You were solving the same exact thing, right? So who is the estimate for?
Payroll.
Yeah, estimate is mostly not for the developers. The estimate is for the project owner and the IT project manager, right? And something you have to realize that, wait a minute, who is benefiting from that estimate? Is Agile benefiting from that estimate? No, there's no estimation in that whole Agile manifesto, right? Think about that. So you just wasted time estimating something that didn't bring any value except to, what? To pad numbers for the manager? Time that could have been spent coding as per Agile Manifesto. So, yeah. But yeah, managers, as managers, we care about who's working on what and how long we expect them to be working on that. The reason for daily meetings is so that we can actually get an update, like a daily update on who's working on what. And as I said, I think a lot of companies, they do the agile wrong. They rely on this Jira process, and they're very much into mentality of we're building something that has phases. So let's say you're building a house or something, right? It obviously has stages, like you build a foundation, you build whatever, and you can plan for that. Some software is the same way. Some software you can say, well, these are the phases of it. Lots of software that you're building, you don't actually know the problems that you'll encounter until you encounter them, and then the amount of time that it will take you to solve them is indeterminate, because until you solve them, you don't know that you solved them. So, yeah, you can't really do Agile on everything. I mean, you can't really do Scrum on everything. You can do Agile on everything, pretty much. So, Agile and Scrum are not the same thing. And if Atlassian, the Jira company, is trying to sell you, you should just tell them, you know what? See, Agile Manifesto, where's the Scrum fit in? Like, which Scrum process benefits any of these items? Because none of them do. Anyways, see you all next week. I'll post some sort of homework.